All right, so we look at our problem. Sorry, I just need to find the problem set now. Beautiful, so I'm a problem set up and I'm going to number 20. Number 20, here we go. So the amount of cloth, okay, used to make 4 curtains is given by the function, and it gives us a nice little quadratic equation there, where x is the width of 1 curtain in feet and a is the total area. Find a width that maximizes the area of the curtain. So if you read that right now, you'd be like, I have no clue what's even going on. We're talking about curtains, like who cares? The one thing that you do want to look for, the keywords, in other words, that you want to look for, is the words maximize or minimize. So anytime you see those words, maximize or minimize, that's going to be minimize, sorry. You are looking for the vertex. Okay, so anytime I see those words, I remind myself, I am looking for the vertex. Yep. Yeah, I was like, did I not see my screen? What is going on here? Nope, I didn't. Thank you. Yeah, always interrupt me. Just me sitting up there. There you go. I had it all set up and I just forgot to hit one little button. It's funny, I just looked over and I was like, I don't think. All right, maximize or minimize is talking about the vertex, because when you think about maximizing something, it means it's a parabola and you're trying to find that top point. And minimize is a parabola in the opposite direction, you're trying to find the bottom point. So depending on your problems. So as I read number 20, I'm just going to remind myself of the equation. So a equals negative 4x squared plus 40x. Okay, it's delightful. And it says we want to maximize the area of the curtain. What is the maximum area? Okay, so the first thing was find the width that maximizes it. The big thing when you're doing these problems is just know what your variables represent. So my x represents, it tells you right in the problem, you just need to go back and remind yourself. X represents the width, and A represents area. So I'm just going to keep that in the back of my mind because a lot of it's just labeling. We know how to find the vertex. We're going to do negative b over 2a. So technically this is a, this is b, there is no c. You can write plus 0 if you really please, but we don't even need it. So we're going to do negative 40 over 2 times negative 4, which gives me negative 40 over negative 8, which comes out to be 5. And we just found the x of the vertex, and we know that x represents width, so that we know the width is 5 feet. And that's going to be the width that maximizes the area. That was the first question. And then it says, well, what's the maximum area? You just take that width and you plug it back in. Negative 4 times 5 squared plus 40 times 5. And that will give me my maximum area. I just threw that in the calculator. What did I get? 100. And it's feet squared when you're talking about area. Is my max area. And then you'll be done. You're going to see a lot of the problems today really just go back to vertex. So look for those maximum, minimum keywords. Know how to find the vertex. Negative b over 2a when it's in standard form is usually your friend. And that's it. So that wasn't bad for 20. So let's look at 21. That one, 21 is a little different. So we're trying to kind of mix in some different problems, but a lot of them will have the same theme. So 21, just in case for the people at home if you don't have it in front of you, says the diagram shows the path of a model rocket launched from the ground. Okay, that's great. So we have a rocket launching, exciting stuff. It reaches a maximum altitude of 384 feet, so that's its maximum, okay, vertex, when it's 16 feet from the launch site, okay? What quadratic function models the height? Oh, so we have to write a quadratic function. How exciting. So we have to write an equation where, as all the other ones, we're usually kind of given them using some information. Hey, we can do that. because this is a problem we know how to do. It's just, once again, the information is presented in a different way, but it's a problem that we know how to do. So let's label what we have. When I look at that little drawing, I can tell the vertex, right? The vertex is at the point, we would say it was 16,384. Right, I went over 16 up 384, that was my maximum. Okay, so if I'm writing this in vertex form, I'm feeling pretty good because I have H and K. But we know for vertex form I need A as well, and I don't just know that, unfortunately. So I'm gonna have to find it. So I'm gonna also look for a point on that little graph that was given to me. And the only other really value I see is 32, where it's hitting the ground. So I'm gonna say that's the point 32, 0. So in order to find that A, I need a vertex and the point. I kind of just look and say, oh, it's hitting the ground at 32 feet. Let's use that as my other point. And then I'm going to plug into vertex form. So this is H and K. This is X and Y. So we would have 0 equals A, X minus H squared plus K, which is 384. So we've had a lot of these problems kind of throughout where you're throwing in the vertex and the point. We have a little bit of simplifying to do, so that would give me what? 16 squared, which is 256A. And I just use my calculator to subtract 384 and divide by 256. And A should come out to negative 1.5. Please don't forget, don't just say A is negative 1.5. Actually write the equation. I feel like that's something you solve. You're like, yeah, I found it. But then you forget what the actual problem was. So the equation would be Y equals negative 1.5 X minus 16 squared plus 384. So we had to write the equation, so we had to take the information that we knew, plug it in, and we went from there. Once again, it didn't say specific form, so use the form that's the easiest. If you have the vertex, use vertex form. Don't overdo it there. All right, so that wasn't terrible either. So I know, once again, word problems are usually like our arch nemesis. We'll just remind ourselves, it's problems we know how to do, it's just presented in a different way. So we'll put a positive spin to it. All right, let's look at 22. So to make an enclosure for chickens, because who doesn't need that, a rectangular area will be fenced next to a house. So there only needs to be 3 sides, which makes sense because one side is the house. There's 120 feet of fencing material. Okay, so we have 120 feet. We want to maximize that space. So first we need an actual equation because we don't have one, so that's important. So that's for A, we'll write the equation, and then for B, we'll find the dimensions that will maximize, aka we'll just find the vertex of that equation, that enclosure. So what we want to do, need to remember to go back to my thing there, is just kind of think about that situation because we need to come up with an equation, which is the important part. So this is number 22. So let me just do a quick drawing here. Oh, actually, it's a fence, you know. Okay, X. So it told us this was X. Hey guys, if this is X, what's this? It's X, it's a rectangle, right? Now we need to figure out how to write this side of the fence, right? So we know that the fence, we have 120 feet of fencing. We know this side is X and this side is X. Does anyone have an idea of how I write this side? 120 total minus these 2 sides, which I'll just represent 2X. Whatever's left over is what I have for that width, right? So what I'm saying is 120 is the total fencing that was given to me in the problem. And then I'm going to subtract these 2 sides. And then whatever's left is what I can use across. Okay, so we're saying, all right, like I'm just kind of getting into the flow of like what's even happening here. We need to write an equation off of that. But just as a reminder of how to find the area of a rectangle, we multiply length times width, right? So to find the area, I'm just multiplying these. I don't technically need that third side. So to find the area, it's length times width. Doesn't really matter which is which, length or width. So the area of this is x times 120 minus 2x. I'm just going to distribute into that to give me 120x minus 2x squared. And then I'll write my equation. I'll just write a equals. I'd like to write it in standard form. I'm going to have to do my vertex in a second, and that just kind of helps me out in that sense. And I just like standard form anyways. But that would be your answer for A. Write a quadratic equation. There you go. Multiply length times width. It was just really finding that side that was like the kind of newer part. And now when it says what dimensions will maximize the area, that just means we're finding the vertex for B. So everything, if it says maximize, minimize, you go straight to vertex. We're going to do negative B over 2A. Remember, C is 0. That's fine. It doesn't even really affect us. So that would give me negative 120 over 2 times negative 2. What's that? Negative 120 over negative 4, which is 30. So remember, like at this point, I'm always like, what did I even just find? Like, I'm just like throwing things in. I don't even know what I'm doing anymore. So always go back and remind yourself, what is x? Like, what did we even just find? We found the x of the vertex. And it was the distance from the house. So that's 30 feet from the house. Okay. But we want, what do we even want? We want dimensions. So 30 feet by what? So you just take the 30 and throw it back in. Oh, this isn't going to be. I'm just going to call this y, not a. That's going to be too confusing. 30 squared plus 120 times 30. And that's going to give me 60. For a dimension, we would just say 30 feet by 60 feet. And that makes sense because if this was 30 and this was 30, that's 60. And then if this was 60, that's 120. So it's just kind of a fancy mathematical way to get that. Once again, you could have guessed some length and width, but you wanted the one that maximizes it. You want the most space. You want the most area. The area would have been 1,800 square feet. All right. So I definitely want to do 23 with you. Then we're going to kind of skip around because things are out of order. And there's a few other things. You'll see the next section. They'll kind of end up being a little similar as we go forward, which is a good thing, right? Because when you see one, you think, oh, that looks like the other one, and I know how to do that. So I want to look at 23. The reason I want to look at it is because our equation is in vertex form, which we're okay with. It's just we want to make sure we're okay with like finding everything that we need. So we have the path of a football travels when Bryce throws it, and it can be modeled by a function, which once again was given in vertex form. And then it asks us a few questions. Where h is the height? Oh, never mind. That's not a question. Where h is the height of the football and t is the time in the air. I thought that was okay. Now here's the question. What is the maximum height of the football? How long is it in the air? And what is the height of the ball at 0 seconds? Okay, so we have a few things being asked here. So when I'm looking at that one, excuse me, which is 23. Sorry, just trying to label as I go. I'm going to just remind myself of my equation. I just need it in front of me, or I lose my mind here. Yep, I totally, thank you. Every time I forget. Or I try to remember it and I still forget. Okay. Forgot to turn the camera on. Always an issue. Okay, so we have good old vertex form. Now the nice thing about the first question, it just says, where what is the maximum height of the football? I can just get that from the vertex. It's right there. So it's nice. We don't even have to do anything. So just as a reminder, we know the vertex is at the point 2.5, comma 12.25. Which one of those is the maximum height? 2.5 or 12.25? 12.25. So this is time, and this is y. Is it what? I'm sorry, they called it h, so I'm going to say h. And that's height. So just know, once again, which variable is which. So the max height is at 12.25 feet. At 2.5 seconds, but didn't ask that. How long is it in the air? So when we're thinking about throwing a football, it's in the air as long as it hits the ground. So for the second part there, we take our equation and we want the height to be 0. Okay, we've done that before, just solving for a variable. So when it's in standard form, we're like, just do a quadratic formula. It's always going to work. It's easy. With vertex form, I don't want to do that because it's going to be a big pain to just rearrange this. So remember, when we're solving something in vertex form, I'm usually going to use square roots. I'm going to try to isolate this, and then I can take the square root of everything. So I'm going to subtract 12.25. So it just depends what's your form and what's going to be the easiest for that form. So take that into account. Remember, do not distribute this. No, that's being squared. So we're going to divide by -1 to cancel that nice little constant there. And I end up with 12.25 equals t minus 2.5 squared. So I'm still solving, but at least I've kind of moved stuff around enough that I can now take a square root. Remember, I take the square root because it cancels the squared. The square root of 12.25, I think it's 3.5. It is 3.5. But please just remember, when you take the square root and you're solving, it's plus or minus 3.5 equals t minus 2.5. And then we would add 2.5 to both sides. That would end up just being 2.5 plus or minus 3.5, but I would actually find the two answers from there. I'd add it once and subtract it once. And they come out to 6 and -1, which I don't care about the negative answer. So it hits the ground after 6 seconds. Oh, that worked for just that little answer there. There's my thing. And last but not least, there's one more question. What is the height of the ball at 0 seconds? Remember, if it says 0 seconds, you can just plug in a 0 for t. That's all it means. So it's really just telling you what to plug into the equation. At 0 seconds would be what the y-intercept is. Technically, it's where he's starting to throw. So he's not starting to throw from 0. That would be kind of awkward. So I'll do this one over here. So what is the height at 0 seconds? I just throw in a 0. And then I'm just going to use my calculator to simplify that side to find that height or that intercept. And I believe it comes up to 6. Let me just check though, because I didn't write it on my actual answer key. It does come out to 6 feet. So that just means, when you start to throw something, it's on the ground. In that case, it was 6 feet from the ground when it started. Okay, so we've seen a few different setups. A lot of them kind of relate back to vertex, depending on the one that you're doing. We're going to keep that in the back of our head. Look for that maximize or minimize wording. So after number 23, we are going to skip to number 39. 39, my friends. 39, 40, and 41 are all very similar. And that's a good thing, because they're not that hard. So that's always the best. So 30, and then I will remember to take this one. So I read it. A small independent motion picture company determined the profit for producing DVD copies of a recent release is, and it gives us some sort of equation there. P is the profit in thousands, N is thousands of units, which are DVDs. How many DVDs should the company produce to maximize the profit? And what will the maximized profit be? All A and B are asking for the vertex. So A is asking for the X of the vertex, B is asking for the Y of the vertex. Hey, right now, can everyone please find the vertex of number 39? Thank you so much. I just want to make sure my attendance is correct. So I'm going to put the pins. You're finding the vertex of number 39. You guys are all here.
Hey, Trey, how are you? I'm all right. Thanks for asking. We're gonna move the AT.
39, shouldn't be too bad, so I'll be in a minute or two.
I feel like my answer can't be right. It's big.
What do you got?
85.
85? That's right up.
128.5.
Yeah. It's actually 85,000 because they told us at the beginning N is in thousands of units. Oh, also wrong thing. You're right. So let's do that one quick, and then you're going to see the next two are kind of the same deal. So we'll go through those ones. And then there's one other problem I just wanted to show you that's a little bit different. It's stuff we know how to do, sometimes just the wording's a little funky. So tomorrow we'll do there's like one other type of word problem. We're literally just going to do one, and then you guys are going to try one. And we can clear up any questions you have, because there will be an assessment after vacation. So we want to clear up stuff before we leave on vacation. So as to not stress ourselves too much, hopefully. But I know we've had a lot, but the main goal was when we got to vacation, you can actually have a vacation and you're not doing math work. So just bear with me for one more day. One more day we can do this. And then we'll have a nice break. There will be nothing over vacay, and then we'll come back, do our thing. So once again, I'm just finding the vertex. I did negative 3.4 over 2 times negative 0.02. Cha-cha-cha, you can do the work out. It came out to 85. Now remember, this would be a pretty terrible, what is this, an independent motion picture company if they're selling 85 DVDs. So we go back and remind ourselves, it's actually in thousands, so I'm going to write 85,000 DVDs. If you just wrote 85, I'd give it to you, but just for context-wise, you know. And then for B, basically we just you can just plug 85 in, don't plug 85,000. So just plug 85 back into the equation to find your P, and that will come out to 128.5. Once again, they don't want to make $128. When we go back, it says P is also in thousands, so I'm just going to write thousands. Or it's 128,500 profit. And there you go. So nothing too crazy there. So the next ones are very similar for 40 and 41. So I'll just go through them quick with you because you kind of have the idea going now, where a lot of this leads back to vertex. For 40, we're talking about a local nursery selling a large number of ornamental trees. How interesting. They've determined the cost per tree for buying and then caring for them. Well, they're like little babies. You have to buy. Well, I guess you don't buy a baby, but you have to take care of it, you know. They have a nice little equation there where C is the cost per tree and N is the number of trees. And the second it says minimize, I think vertex. So always look for that keyword. So I'm just gonna do the vertex. Okay, I can do that for 40A. Sorry, I'm making sure my computer's up. As I'm looking at my thing, negative B would be negative 0.03, okay, over 2A, so that's 2 times 0.001. So none of that I want to do in my head. I would just throw that into a calculator, and it should come out to 150. So think about what you're talking about. We're talking about N, and that's the number of trees. Okay, so 150 trees. Good stuff. What will the minimum cost be? Oh, we just take that and throw it back into the equation. So for B, the minimum cost is oh my God, I can't remember, 0.001, sorry, this is a long equation, squared minus 0.3 times 150 plus 50. And once again, you're just throwing that into a calculator to find your C. And that is 2750. Okay, that's not bad. No, that's it. Okay, I'm sorry. I thought there was another part. I was all into it, and that's actually just the next problem. Okay. 39, 40, very similar to each other. 41, also going to be very similar. I just want to point one thing out to you. It says find the maximum height and the corresponding time of an object. So at what time is it at the maximum height, aka what's the vertex? It tells me the initial velocity is 40, and then it gives me an equation. You just have to plug the velocity in. It's kind of a weird way to set it up, but you know, life here. So for 41, it gives us the equation, h equals negative 5t squared plus vt. You just have to look and say, oh, I know, it tells me v. It's kind of a weird thing. So v is 40. So just as a heads up on that one. If you started doing it like, wait a second, that doesn't make sense. And then we're just, once again, finding the maximum height and the time that goes with it. So we'll do negative b over 2 times a. That's negative 40 over negative 10, which is 4. So think about what 4 represents. It represents the x, or in this case, the t. So that's 4 seconds. And then we'll just plug that back in to find the maximum height. So you're seeing we're doing a lot of the same steps over and over and over again. And that gives me my maximum height of 80 feet. Beautiful. God, I hate having this last period. I always feel so stressed. It's stressful. Okay, so let me look and see what other word problems there are, on which ones we're gonna be finishing up here. And so we just did those, and scrolling and scrolling. Oh, scroll away, Mr. Sherman. Okay, we get to 58. That's the next word problem. For 58, we have the length of a car's skid mark as a function of its speed. Exciting stuff, where L is the length of the skid mark and S is the speed in miles per hour. If the length of the skid mark is 220 feet, find the speed in miles per hour. We'll set that one up. And then there's one other thing I want to show you on 60. Those will be kind of our last two here. Nowhere in 58 does it say maximize, minimize, so you're not doing the vertex. So sometimes we just get into like the habit of doing something and you just do it because you did it in the previous one. Please only do vertex if it's asking to maximize or minimize. For number 58, we have this equation. It's kind of funky / kind of annoying, but it is what it is. We have calculators, so oops, that's a mess. So calculators make everything better. That's not an equals, that's a plus. So if that was my equation, all it asks is if the length of the skid mark is 220, find the speed. All you're going to do is for length, put in 220. And then solve that one. So you would have to set it equal to 0, and then I would do quadratic formula. So So it might be a little messy, but once again, you're just estimate it, use a decimal. So, good old word problems, we do use decimals because it just makes a little bit more sense context-wise. So you guys can try that one. 59, you guys should be able to do. It's just asking for maximum height, maximum blah, 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 blah. So there is something on 60 I want to point out to you. So can everyone look at 60 for a moment? I'll put it up on the screen ski. There's one thing I want to point out, and I'll give you these last few minutes to finish up those problems. So Mr. Unlucky, I mean, with a name like that, he shouldn't go into business, I'm gonna be honest with you. But his company can be represented by an equation that's given to us, where Y is the amount of profit in hundreds of thousands of dollars, okay, so maybe he's not doing that bad. And X is the number of years in operation, so hopefully the more he's in operation, the more he's making here. He realizes the company is on a downturn, and wishes to sell before he ends up in debt. Probably a good spot, Mr. Unlucky. So it asks us a few things. What's the maximum profit? Oh, you can find that, right? You guys can go up and find the vertex. I only said the word vertex 1,000 times today. So you go up and find the vertex for A. Excuse me. A and B are the vertex. So A is the X and B is the Y. It's when we get to C and D, I feel like the wording is just a little weird, and if you've never seen a problem, which we haven't, it might be a little funky. So let me just give you a visual of what's happening on C and D. So I'm just gonna kind of quickly show you a little sketch, and then hopefully it will make more sense. So when we think about Mr. Unlucky here, he actually started, you start a business, you're not making money right away. He actually started by putting some money in the business. So the y-intercept of this was -4, I believe. I'm on the wrong page. No, I'm not, I'm on the right page. The y-intercept was -4. So he starts down here, and over time, he starts making some money. Okay, he finally earns his money back. And then he starts making a profit. Oh no, downturn. No, Mr. Unlucky, no. Okay, there you go. And then down there is losing a lot of money. So if I'm above the x-axis, I'm making money. I'm making a profit. If I'm below it, I'm losing money, unfortunately. So for C, it says, at what time will it be too late to sell the business? When will he start losing money? He's going to start losing money right here, right? Right there, he's going from making money to losing money, not at the big pain. So what you're going to find for C is find the x-intercepts. So just use quadratic formula. Right? So you can use quadratic formula. You're going to get 2 x-intercepts. You're going to use the second, the higher one, because that's when he starts. That's when he starts making it. That's when he starts losing it. But just for a visual, hopefully that makes sense. And then D asks, in how many years will he break even? So you're probably thinking, well, that's like the same thing. It's really not, because he started here. So he breaks even when he ends up back there, okay? So for D, for this one, I'm setting the equation equal to 0. And for this one, I'm going to set the equation equal to where he started, and he started at -4. And that's the difference. I feel like when you read that, you're like, that's the same thing. It's really not the same thing, because he didn't start at 0. So I just wanted to explain that concept to you. Oh, as I fall into my chair. Oh, gosh, it's always a rush last period with dismissals and all that fun stuff. So tomorrow